Okay, so in this tutorial we are just continuing on pandas.series. So last time we were doing this aggregate function. Uh, so using aggregate we can specify one or more than one aggregate functions which we want to apply on a series. Let's say we have a series having elements 10, 12, 13, 15. We want to find out the minimum and the maximum value. So we just say series.agg and we specify the functions that we apply on this particular data, and in the output we get the corresponding result. So minimum value is 10 and the maximum value is 15. Okay, now let's say what is keys. Keys simply returns it's just an alias for the index. It will return you the index values. Let's say we have a series S and its data is 1, 2, 3, 4, 5, and the index is A, B, C, D, E. And we say, so we are just printing the series here, A, B, C, D, E, the indexes, and this is the data. We say S dot keys, and it will give you the index values of this particular series. Okay, now another important term is the group by. So let's say we have a series. Okay, this is the data 10, 11, 12, 13, 14, 15, 16. That is fine. Now index, these are the different indexes A, B, B, C, C, C. Okay, and this is the name of this particular series is brand. So we can specify the name of the series also by just using name equals to argument. So now the series gets created. Now what we want is we want to group by based on this let's say index and find out the mean value. So we see here A has two values 10 and 11, B has two values 12 and 13, C has three values 14, 15 and 16. So we want to group by the index and we want to find out the mean value. So what we need to do is just simply say s dot group by. Okay, we want to grouping. Now we want to group by what? By on the basis of index. So in by we specify s dot index. So it will be grouped based on this index values, and we want to calculate the mean. So it is grouped on the basis of A, B, and C, and the mean value gets calculated. Either we can specify s equals to index using by, or we can get the same result if we are specifying level equals to 0. So it is more useful when we have multi-level indexes, and we can specify more than one level, but since it's just a single index, so we can specify level equals to 0. It will give you the same result what we got in the previous syntax. Now one very commonly used function with the series is the value underscore counts. What it does, it will give you the count of the unique values. Let's say we have a series in which we have elements which are repetitive. Let's say this is a series of favorite pets. Let's say we ask a couple of people what is their favorite pet, then and they replied like dog, cat, dog, parrot, and we want to find out how many people uh, said what is their favorite pet in terms of the count. We want to find it out. We just simply say that series dot value underscore counts. So it will just find out what are the unique values, and it will give you the frequency of this of those values. So cat, the frequency of cat is 3. It means three people said their favorite pet is cat. Parrots, so two people. Dog, two people. Pigeon, one. Okay, now if you want to find out the relative frequency, we have to pass an argument to this value underscore counts. This is called as normalize equals to true. What it does is just simply divides each value by the total sum. So it will divide. So total is 3, 4, 5, 6, 7, 8. It will divide 3 by 8, 2 by 8, 2 by 8, 1 by 8, and it will give you the relative frequency of each of these values. So favorite underscore pets is the series, and dot value counts is the name of the function, and we are specifying this parameter normalize equals to true. It will give you the relative frequency. Now, if we want to now you will notice that this value underscore counts ignores nans. Now, if we want to include nans also, let's say if the data is such that it has some nans, which is not a number, that is missing value, and we want to these also get included in the output. By default it ignores nans and then gives the result. But if you want to find out, I mean, if the intention is to find out, okay, if there are missing values, then let's also count them and see how many of these are the missing values. Then we can specify another parameter like to count out the to count the values. Okay, and then we can also drop the values of the NAs wherever the NA values are coming. So in this case, what we are doing is s dot value underscore counts, and we see drop n equals to false. It means whatever any values are there, don't drop it, just include it as a part of the count. So we are getting nans as 2, so it means there are 2 missing values in this series, and just are the other values. Okay, so that way we can understand, okay, what percentage or of the data is having the missing values. Now if you want to remove the nan values, that is the missing values, we can just simply use s dot drop na. So drop na removes all the nans or the missing values, and if we specify in place equals to true, it will modify the s. If you do not specify in place equals to true, then it will show you the output, but it will not change s. But if you want to remove the NAs and modify S series, then we have to specify in place equals to true. So as we see from this S, these two NaN values are removed, and in the output we get indexes and their values. Okay. Now another thing which is interesting is find out, let's say, the rolling sum. Let's say we have a series of few numbers and we want to find out rolling sum of, let's say, window 3. That is, we want to find out the sum of 3 elements, so that is 10, 11, 12, and then another 3 elements, 11, 12, 8, and then another 3 elements, 12, 8, 7, and so on. Then that we can achieve by specifying this rolling function. So what we have to do, just series s dot rolling window equals to 3, that is starting, that is in each window we are taking 3 elements and we are doing the sum, and in the end we are specifying drop na. So why we are doing drop na? Because initially when it starts there will be, it will take, because our window is 3, so initially when it starts from here 10, it will take 2 previous values which are not there as nans or missing. Similarly, when it comes here, it will take first, second, and the third value is missing, that will become nan. So we are dropping those nans so that the count actually starts from such that it adds 10, 11, 12, and 11, 12, 8, 12, 8, and so on. So that's why we are dropping the NAs. So that's how we calculate the rolling sum. Now often there is a requirement to find out, okay, what are the top n elements and smallest n elements. Let's say we have a series which is brands, and sorry, we have brands which is a dictionary, and let's say these are the different brands, A and B, C, D, E, F, and these are the prices, the price of the respective brand. And let's say these are the brands of a bag. So what we are doing here is we are creating a series S, let's say using pd.series, and we're specifying this dictionary brands. So one thing to note, when we are passing a dictionary, then the values of the dictionary becomes the data, and the keys of the dictionary becomes the index. So we are saying pd.series brands, that is its value will become the data, and the keys will become the index, and the name is bags. So the name of the series is bags. Now we just simply print s, we get all the keys a, b, c, d, e, f as the indexes, and in the series the values of the dictionary becomes as the values of the series, and we say the name of this particular series is bags and its data type is int64. That is fine. Now we want to find out what are the top 3 expensive brands. So we have to use n largest. N largest is the function. So we apply it to the series. So we say s dot n largest, and then we give the number, like we want to find out top 3 or top 5, whatever number we want to find out. We just have to specify n equals to 3. So we get bags corresponding to top 3 brands in terms of their prices. So let's say B, A, B, and C. So these are their prices. These are the top 3 within this list. Similarly, there is n smallest, so it will give you the smallest n numbers. So we want to find out the cheapest 3 brands of this bag. Then we say s dot n smallest, and n equals to 3 small n. So it will give you 3 smallest values, or that is 3 smallest prices of the bags. That is the 3 cheapest bags. Yeah. Now, sometimes there is a need to find out the data between a given range of values. So let's say we want to find out all those bags from this particular series which fall within, whose prices are within the range of 1000 and 3000. So we say s dot between, and then we specify the starting price 1000 and the highest price, let's say 3000. And so what it will do, it will return true or true false corresponding to each element, and then we are putting it just like a boolean indexing for the series, and then in the output we will get only those records, only those elements from the series which satisfy this particular condition, that is for which true is returned. So two there are three brands C, D, and E whose price is between 1000 and 3000. Now let's say we have a data of sales, and we want to find out what is the percentage change in the successive values of the series. Let's say we have sales data, maybe a monthly sales, and we have like 400 on month one. On the next month we have 600. Then we have 800 products were sold, then 900 products were sold, then 750 and 1000 and so on. Now we want to find out what is the percentage change as we move from left to right. So we say series dot pct underscore change. So pct underscore change will compute the percentage change as we move from left to the right. So what was the change? What was the percentage change in the value? So from 400 to 600, because initially it's a four, there is nothing before 400, so initially you will get none for the first one. Now when it went, no, when it went from 400 to 600, so there was a 50% change. 600 to 800, there was a 33.3% change, and so on. So it's a very handy function to calculate the percentage change among the values. Next is the quantile. We just simply have to just call the function quantile and specify the value, the which quantile value we want to calculate. So series.quantile, let's say 0.50. So this is the 50th quantile gets calculated and it's returned. Another very good function is the align function. So basically, let's take an example. So let's say we have two series x and y, okay, and these are their values 1 2 3 4 10 20 30 40, and their indexes are a b c d and a b c d e. Now what we want to do, we want to compare these two series such that whatever is common between these two series, that should get returned, and that should get returned as a separate sub-series. Let's say if we see in series X, the indexes are A, B, C, D. In the series Y, indexes are A, C, D, E. So the common index is A, C, and D. So we want to do a comparison. It's like an inner join between these two. If you consider these two as tables, let's say we want to apply an inner join between these two, and then whatever is common between the indexes. So based on that, the value should return from X and Y, and we want to capture it separately. So we can use align function for that. So we are saying X, this is a series, we want dot align, and then we are passing the another series Y. Now how it should be compared, we want to do kind of a inner join kind of operation. So we say join equals to inner, and then level equals to 0. That is, we want to compare what? We want to compare the indexes. So wherever the index is matching, that is the inner join. So A, B is not matching here, C is matching, and D is matching. So three indexes are matching, A, C, and D. So from this series X, the values corresponding to index A, C, and D are returned. Similarly, from series Y, values corresponding to the matching index A, C, and D are returned. And these two returned smaller series are captured in S1 and S2. And that's what we are printing, S1 here, S2 here. S1 is what we are getting from X corresponding to the matched indices, and S2 is what we are getting from Y corresponding to the matched indices. Okay. Now, moving on, let's take another function, which is the drop function. Let's say we have a series, and if we want to drop a particular label from that, then we just simply specify, let's say we have series X, and it is having some values 1, 2, 3, and the indexes are A, B, C. We just print this series X. So this is indexes, these are the values. We want, for some reason, we want to drop some labels. So we just simply say series dot drop. So in this case, X dot drop and the label name. So it will remove that label A and it will return you the remaining values. In case if your series is having some duplicate values, then we can remove those duplicates values using drop underscore duplicates. So let's say we have a series A and it is having values. Some of these values, like we see 10 is duplicated. Then we just simply say series dot drop underscore duplicates. It will drop all those duplicates. It will just retain the first a value which actually got duplicated, and the remaining duplicates like this 10 and this 10 got removed or got dropped. Head, it will return the first 5 elements of the series. Let's say if we have a big series and we want to just have a glimpse by looking at the first 5 elements, we just simply say series dot head. It will give you the first 5 elements. Another uh, handy functions are id max and id min. So within a series we can find maximum and the minimum values, but if you want to find out the location at which location those maximum and minimum values are present within a series, then we use idx max and idx min. So we say a dot, that is series dot idx max and series dot idx min. So maximum value is 30 and it is at index 4, it's returned. Minimum value is 10, this is at index 0, that gets returned. So another very handy function is in. Let's say we have a series and it is having some list of cities, Delhi, Mumbai, Chennai, and we want to find out whether elements of this particular series match our given list of cities. So that is our given list of cities is to Pune and Mumbai. So we want to find out whether the elements of this particular series are matching our given list. So we say cities. This is a series dot is in, and we specify the smaller list that we want to match. So it will compare Delhi, whether Delhi is present in Pune and Mumbai. No, it is false. So it will return false. Mumbai is present in Pune, Mumbai. True. It will return true. Chennai is in Pune, Mumbai. No, false. So it will return false. So this is very handy if you want to find out some of our values, whether these are present in a given series or not. So we can use in those scenarios is in function. The next is the re-index. So let's say we have a series S and we want uh, its values are 1, 2, 3, 4. Indexes are ABCD, ABCD. That's fine. Now, for some reason, we want to re-index the labels. Okay, we are not happy with the way the labels are presented here. So what we can do is we just use S series dot re-index, and then we specify what is the new label that we want to specify. So let's say we want the values to appear in the form of B, C, D, A. So okay, and we want to add another index Z also. Okay, so what it will do, it will create the new series, return the new series where the index labels will be in the form of B, C, D, A, the order which we have specified here. So B, C, D, A and Z, and the values are returned corresponding to whatever values were there in the original series. So for B it was 2, for C it was 3, for D it was 4, and for Z it was 1. Now we have added one extra index Z, and there was no index Z in the original S series. Okay, so it will return nan, that is because it didn't find any value for that index in the original one, so it will return obviously nan corresponding to it. And because nan is a floating representation of the missing value, so that is why the data type of all these got changed from integer, if you see, to the float one. Okay, so that's how we can re-index the labels of an index. Now another thing is, if we want to include index as a part of our column. Okay, let's say we have as index labels as city names and the values as the population, and we want those city names to get included as a part of the column. Then we can use reset underscore index. So let's say we have this S, okay, S is a series which is there. Now we want these columns, these indexes to be represented as column next to it, next to the values. So we say S dot S underscore new. Okay, we're taking an S underscore new, so S underscore new is here. So we're saying reset underscore index. So all these indexes become a part of additional column, if you see. And drop equals to false means that we want to retain those indexes, and the name equals to value. So the whatever heading we want to specify for this particular values, we pass here as a name. So if you see, these particular index labels are coming here as an additional column, and they got their header as index, and these values are coming here, and because it did not had any header, so whatever we passed here in name, that particular value is gets presented here as the header of that particular column. So it's kind of a data frame that we are creating by adding index labels as one additional column. Okay, now the next is the where function. Let's say our requirement is to replace all the negative values with zero. Let's say we have a series S, and we want to find out wherever any negative number is present, replace it with the zero. So the way where works it, we specify series S and dot where is the function, then we specify the condition, like which condition should be checked, and wherever this condition is true, there it replaces that value with whatever we specify as other. So we are specifying as other equals to zero. So what we are saying here is S dot where, that is wherever S is greater than zero, it will return. So wherever this condition is true, it will return those, sorry, wherever condition is true, it will return those elements, but wherever the condition is false, those elements get replaced with zero. So what it means, s is greater than 0, so it is yes, it is greater than 0, so it will return 1. 3 is greater than 0, yes, it will return 3. And if you see, minus 5 is greater than 0, that is false, and it should get replaced with other equals to 0. So if I run this, other gets replaced, this minus 5 gets replaced as 0. Similarly, 6 and 7 are greater than 1, so they are returned as it is, but wherever this condition stands false, that is minus 9 is greater than 0, that is false, so we replace it with 0. So basically in where we are, what we are doing is we are just specifying a condition. If the condition stands true, we return whatever the original value is, and if the condition is false, then we have to replace that value with the value we specify with the other. Opposite to where, there is a mask function. So in mask, wherever the condition is false, that value is written as it is, but wherever the condition is true, that gets replaced. Let's say we have a series S, and it is having values 4, 5, 9, 6 and 7, and we want to replace 9 with 0. So we use S dot mask, so it will, and then we specify the boolean condition here, S dot is NA, and we specify the other equals to 0. So if the condition is false, it will return as it is, it will return the original value. So so if we start comparing 4, it is not an NA, so that 4, whether it is a NA, this is false, so we return 4. 5, is it NA? No, this is false, so return 5. This is nan, yes, this is true, so wherever we get true, that gets replaced with 0. So just like mask and where, these are opposite to each other. In where, wherever the condition is false, that gets replaced. In mask, wherever the condition is true, that value gets replaced with what value specify in the other. Another is another method or function where we can which we use very frequently is to replace the missing values is fill any. So let's say we have a series S and it has few nan values, then we just simply say s dot fill any and we specify the value. So what wherever nan is present, that value gets replaced with 0. Next function is sort. So in sort, we can specify the order also, but by default it takes ascending order. So we just simply say s dot sort underscore values. It will just sort based on the values of the series, and it will give you the output. Now, if we say ascending equals to false, then it will give you output in the reverse order. So if we change it here, ascending equals to false, it will give you the reverse sorted. We can sort on the basis of values. So by giving sort underscore values, we can also sort on the basis of the index. So let's say we want to sort on the basis of index, then we can say s dot sort underscore index. Then means these indexes will be used for sorting purpose, and we can specify the order whether it's ascending or descending. We are saying here we are saying ascending equals to false, so it means give it in the descending order and sort on the basis of the indexes. So 4, 3, 2, 1 are the indexes in the descending order, and there are the corresponding values. Just last function for the day is the not any. So basically, it will check whether the element is any or not. If it is not in any, then it will return true. So using this logic, we can just filter out also all the NAs. So what we are doing here is the Boolean indexing. We are just finding s dot not NA. So all the elements which are not NA will return true, and then based on the Boolean indexing, we are actually printing those elements. So we learned a lot of handy functions which we use in the day-to-day with series. So in the next, we'll cover some more functions. Thank you.